So from one person talking about feelings and emotion, we're going to switch gears here a little bit, and we're going to go to a good friend of mine, a gentleman that I have dubbed Dr. Greg Sterick. He used to just be Greg Sterick, PhD, but I have an affinity for calling him Dr. Greg. So Dr. Greg is going to come up and talk about how data drives better decisions. Dr. Greg.
All right, great. Hello. How's the audio? Sound good? Okay, good. So as Tyler introduced me, I'm Greg Sterick, and I'm a data scientist at Ezoic. And just a little bit about my background. Tyler actually didn't give me my doctorate. I got that on this continent, actually. And I got my PhD in Switzerland in theoretical biophysics. And in that PhD is a lot of like statistical modeling. I was studying the nervous system and how ions get in and out of our cells and how nerve impulses are transmitted throughout the body. And that led me to a postdoctoral fellowship at the University of Wisconsin, where I studied actually neuroscience itself. And I was like electrocuting heart cells and studying cardiac arrhythmias. And all that was really great, but I really liked the statistics that I was really doing back in my PhD, and I wanted more and more data. It's one thing to sort of electrocute like 5 heart cells in a dish and then publish a paper and say like, okay, now we understand how cardiac arrhythmia works. It's another thing when you have billions of impressions coming through, and then you can actually start to make some interesting insights into what's actually happening when you have data on that scale. So. Actually, my first job, which is not up on that slide, was I was a teacher, a high school teacher, prior to going into grad school. So I'm going to start with a little bit of a history lesson that I'm sure everyone sort of knows already. But I kind of want to tie this in with publishing in general. So publishing has taken many forms over the last few millennia, but really it's all about it's sort of what publishing has done is transitioned us from the prehistoric into the historic era, because now we had a way to like record our histories and share it over time. So it started with stone carvings, and Shelby and I made a field trip to go look at the Rosetta Stone this week before we came to the event, and that worked really great, except it's really hard to do. It takes a lot of time, and it's really hard to get your publication out there because it doesn't actually move, right? It's an immobile object. So paper came around right around the 2nd century, and paper's great. It's lightweight. You can actually turn things into books and write larger and longer script, but that doesn't really scale well because you have to write every single page over and over and over and over again. So printing came around in around the 15th century, and that was sort of the first printing press. And the printing press was great because instead of having to write every single page over and over again, you could set the type on a page, just put ink on it, and then crank a machine over and over and over again to keep making the same publication and the same print over and over and over again. So it was scaling up the productivity of publishing, and that was around, and that machine has been around until really the 20th century, and that's when we sort of have this advent of digital publishing. And digital publishing has been revolutionary, from the consumer's perspective, because it's easier than ever to actually consume. We can have, if you want to know just absolutely anything, you can look it up and have the answer in like 2 seconds. But it's made publishing actually kind of harder it's made it harder to thrive as a publisher because now there's more and more competition. Because the barrier for entry into publication is tougher, the barrier for entry is easier. So to sort of stay ahead of that curve, A/B testing has sort of taken fold. You couldn't really A/B test on a printing press because it takes forever to actually set the type, but in digital publishing, you can roll out 2 different versions of your site and actually test to see which one does better. So it's easy to actually conduct these experiments, and all you have to do, as you know, is just sort of define what it is you're looking for. Like, do I care about my click-through rate, or do I care about CPMs on this impression? Do I care about EPMV? Do I care about time on site? Whatever it is, whatever your target is, you can go ahead and define it, and then move things around and see what actually moves that number, and then you can say, okay, this is good. I'm going to follow this. So You guys all kind of know that. I'm not teaching you anything you didn't already know, so I want to give you something that you don't know. And this is actually something from our data set at Ezoic, which just popped up just very recently. And so this was a pretty striking statistic that I found, which was that US visitors were 50% more likely to click on top of page impressions than anywhere else on the page. So this is top of page for the US, and then all the other impressions on the page, click-through rate. When you compare that to the rest of the world, that effect goes away. So I thought this was really striking, and so I threw every statistical test I had at it because I just didn't really believe it, and it passed every statistical test that I could throw. So if you actually want to say, okay, this is an A/B test, I ran this test, and I see that US users are clicking on that top of page impression, you could actually turn it into some code and say, if the visitor country is from the US, then I'm going to show the top of the page. If not, then I won't show the top of the page. So that's a little Python. If you're not on the coding side, you can just sort of think of it as a flowchart. You've got a visitor, they're from the US, show the top of page. Otherwise, no. So I dove a little deeper into this phenomenon because I thought it was a little strange. It's pretty interesting. So I started to look at traffic sources. And this is where it got even more interesting. So coming from Google, if the traffic source was through Google, they were even more likely to click on that top of page ad. If they came from Facebook, they were actually less likely to click that top of page ad. Again, throwing all the statistics I had at it, this is still checking out. So we can actually then expand this Python code and say if they're from the US and they're from Google, then yes, show the top of page ad. If they came through Facebook, then don't show the top of page ad. Otherwise, sure, let's show it. And then if they're from somewhere else, then don't show it. So this is starting to turn into a very confusing sort of flow chart, and it's a sort of combinatorial explosion that's going to happen because if we start to add more dimensions to this, as you can imagine, if you add other countries, it gets more and more challenging to actually start to implement. So now this is actually my least favorite part of the talk, which, as with my background as a physicist, I love laws, and here there are no laws. So it starts to get a little more tricky. So that statistic that I showed you passes every statistical test I have, but there's some catches. The first catch, this effect is only true on 60% of the domains. So for a little bit more than half of you, this is probably true on your site. And then for a little bit fewer than 40% of the people in the room, this is not true. So this would be something you have to go through and dig through yourself to find out which one, which group do I belong to. So when we go back and actually look at this, this plot from the previous slide. This was over 6 months, so this was tons and tons and tons of impressions. But when I actually look back over 2 years of data, this effect starts to vanish. So now it becomes interesting, and this is where statistics gets really interesting, because what is going on here? So there are some explanations that we could kind of dream up for why you see this effect appearing. One is that maybe in the last 6 months, there's some new user behavior changes. Maybe people are just becoming more likely to click on the top of page ad. Maybe advertisers are changing priorities in the way that they're spending, and they're putting a lot of their budget in the top slot, and then there's more competition, and so the better ads are winning on the top of the page. It could be a seasonal thing. Maybe over the last 6 months, over those 6 months of the year, users are more likely to click on the top of page ad, but when you look at the other 6 months of the year, they're less likely to click on the top of page ad. I don't think that one's necessarily true, but it could be. And then what's really likely is that this is actually a false positive. And so this happens all the time in statistics, where you could say, oh, I'm 95% confident, but that means 1 out of every 20 things that you look at is going to be a lie. So this is where we get into some of the limitations of A/B testing. So first, like I said, is that numbers lie. We can think of things like CTR and a CPM and an EPMV as that's a great metric and like a good north to kind of target. But the catch is that that's one number that's representing, in the case of this top of page CTR plot, that's representing billions of numbers that we're distilling down into just one number. It's a summary statistic. And so what that one number means is it's a representation of an entire population. So another problem is that test groups have to be random. So when you look at just that 6-month block period of time, are you looking at the second half of the year or the first half of the year? And is that really representative of your overall entire population? Also, the math to do A/B testing is not really easy or straightforward. You can use a p-value, but like I said, if you use 95%, a p of 0.05 is significant, then 1 out of 20 of your experiments are going to fail. You can use Bayesian methods, which are better, but when you get into Bayesian methods, the math gets really complicated, and you have to decide what prior distribution you're going to use, and that is always. Academics will debate on that. There are conferences where people debate on what the best one is to use. And lastly, A/B testing is also not responsive to changes as they happen. So you can run your test and say, okay, this looks good, and I'm going to run it. And then you make that decision, and you use that decision and carry forward into infinity. And so at what point do you realize, actually, things might be changing in the system? And A/B testing, you're kind of stuck. So I saw a little A/B test in the wild. And obviously this isn't really an A/B test, but let's just kind of pretend that it is. So we have 2 water bottles here on the shelves, and there's a yellow label and a red label. It's the exact same water, same barcode, same everything. So we can do a little simple poll. Who likes the yellow water label better? Who likes the red water label better? Interesting. So last time I showed this, it was reversed. So it was majority yellow, and actually the red one won out. So for whatever reason, Arrowhead Water decided we're going to get rid of this yellow label and phase in a red one. And this sort of gets to one of the things Tyler mentioned this morning, is that we have this A/B test, and some of you, actually the majority of you, preferred the yellow. So you have this A/B test, but you have an AA implementation. So what happens to all of you who like the yellow water? Then you're going to go thirsty. So. What I do at Ezoic is AI, and why I love AI and really see it as the future, and obviously I'm not alone in saying that, but it has a lot of great advantages over A/B testing. One is it reduces the data mining. You don't have to dig through the data yourself and say, okay, well, what happens if the visitor is from Canada? What happens if the visitor is from Great Britain? What happens if the visitor is from Switzerland? It actually outsources all of that for you. It eliminates hard coding, which I'll show you in a second. So you don't have these crazy flowcharts of Python code. It also is robust to changes in patterns over time. It's machine learning because it is learning. So as the conditions change, then so too will the output of your algorithm be. And lastly, it outsources the math. So all the hard math questions are already baked into the software suites that do this. So a great way to sort of think about how AI works is, let's say we want to make something that predicts whether or not something is a dog. So what is a dog? So we can come up with sort of 4 defining metrics for what make up a dog. I'd say, if you ask me what a dog is, I'd say it's an animal, it's a mammal, it barks, and it walks on 4 legs. So we could put this into a little flow chart and say, pass through different pictures of animals or different anything really into this and say, is it an animal? Yes or no. Mammal? Yes or no. Does it walk on 4 legs? Yes or no. Does it bark? Yes or no. And if it answers yes to all of these at all of these branches, then we can say it's a dog. If it is a no anywhere along the line, then it's not a dog. So this is actually a pretty simple algorithm, but there are some complications to this. And one case would be this dog here, Milo. He's one of the dogs of Ezoic. And Milo would fail the dog test according to this algorithm, because obviously there's going to be some outliers in the data. So if you look closely, you can see where Milo fails. Milo only has 3 legs here. So if you run Milo through this algorithm, he will fail. And Milo is a very, very, very good dog. So he should not fail this test. So what AI will actually do is it starts to learn what's the most important defining characteristics of dogs. So you show it a dog after dog after dog after dog, and it'll say, okay, yeah, all of them are animals, all of them are mammals. And it encounters Milo and it says, okay, Milo's a dog, but Milo can walk on 3 legs, so it learns, okay, that's less important than whether or not it's actually a mammal. And so it starts to weight these factors and will start to account for those outliers. So this is actually modeled after the systems that I did back in grad school, which is just like how a neuron operates. Neurons have these dendrites all along here, which are just basically like signal inputs. And along those dendrites, neurotransmitters come through, and this neuron just sort of weights all of the signals that comes in and will say, like, yes or no, is it a dog? So it takes in all these signals, weighs them, and then decides whether or not it's going to fire. So if we take this sort of dog abstraction and put it into something that's, you guys are probably much more interested in, like CPMs on ad impressions, we can apply these same methods to make better decisions using a more relevant system. So in this case, I have sort of a dummy example here where we have 2 CPMs. Let's say we're going to decide, we're going to put 1 impression on the page, and we want to decide if it's the top of page or a sidebar. So the simple thing to do would say, well, which one makes more money? And we can see, okay, well, the top of page has a $3.02 CPM, sidebar has a $3 CPM also, so it's kind of a wash. And like I mentioned earlier, this CPM is a summary statistic. So it is describing billions of impressions over time. So you may say, okay, I know what to do. I will look at the distribution of the data to learn maybe there's something's different about the top of page and the sidebar CPMs that I can learn a little bit and maybe make smarter decisions. And when you overlay these distributions, you'll see actually they're pretty much identical. So most of them are around $3. Some of them are really high. Some of them are pretty low. But essentially, it still looks all the same. So we can start to break it down by country. And if we start to break down by country, we can pick the highest one for each country. And so when we go through and we do it this way, we have Canada, France, Great Britain, India, US. And what you'll notice here is there's still not a lot of difference between each group on the page. So again, we can pick a winner, but it ends up actually not really mattering. So if we go back and think about this flowchart model, we could say, okay, if the visitor is from the US, they get the top of page because here they are, the highest one is the top of page. And then everyone else, the sidebar one, but just barely. So then everyone else would get the sidebar. So this starts to get more and more complicated as we start to scale it out. That was only 5 countries, 1 position. So what we can do instead is use something like TensorFlow, which is a Google product. Well, it's an open source product, but started here at Google. And TensorFlow is a machine learning software that will automatically do all of this data mining for you. And so here's some code to actually run this through TensorFlow and to let TensorFlow actually do all of the dirty work. So the first thing that you have to do is just basically tell your computer, okay, open TensorFlow, and then use something called Pandas, which is basically like Excel for like CSVs formats. And then you tell TensorFlow what it is you are interested in. Let's say I'm interested in the country and the position and the traffic source. So all you do is you say TensorFlow, create columns that look at country, position, and traffic source. So that's all that's going on here. Then the next thing, you just tell TensorFlow what type of model to use. So in this case, I'm using a DNN regressor, which is a deep neural network. A regressor is just a thing that predicts a number. So we're going to predict the overall price. And then lastly, you just say, OK, now TensorFlow, go. So here you're just saying the X, all your inputs are the country, position, traffic source, and then the Y is what you're predicting, which is CPM. And then you tell it to train. And what actually ends up happening with when TensorFlow starts to go through this data is that it starts to learn that there's actually more in this data than what we could find just going through it by hand. And the way that this works is it just weights all those features, country, position, traffic source, finds the ones that are most relevant, and then starts to use that to make its predictions. And so what ends up happening is it finds that it does matter by country, position, and traffic source. And if we predict what the actual overall CPM would be, it's like $3.39. So that was like 12% increase just left on the page from one impression. That was just 8 lines of code in TensorFlow. So to wrap up my talk here, I kind of want to revisit the first slide. So when I take a step back and sort of look at this, the thing that really pops out to me is each of these, the time period that each of these things was around was like millennia. So we have thousands of years until paper comes out, 1,000 years until the printing press, and digital publishing has been around for like what, 20 years, 30 years. So we're really like at the forefront of this technological innovation. And we're really lucky because it's happening at the same time that there's this big data revolution that's happening at the exact same time. And those tools that are being generated in-house and open for everyone can actually solve these same problems that we're facing as digital publishers. And so I think it's what I'd like to leave you with is like, are you ask yourself, are you doing this A/B testing where you can get stuck in a rut and do AA implementation, or do you have a more dynamic solution for these digital publishing problems? With that, I'd like to say thank you.
Thank you very much, Dr. Greg. I've seen Greg give that presentation a bunch of different times, and I'm always surprised to learn what is a dog. It's always really helpful. And Milo is a dog in our office, and Milo is very much a dog, despite the fact that he failed Greg's first test. So thank you, Greg, for fixing the test for Milo. Real quick, how many of you guys know who Mark Twain is? So Mark Twain is from the home state that I'm from in Missouri, and he has a famous quote. He has many, but one of which is, supposing is good, but knowing is much better. So Dr. Greg, Brendan Judge, they both talked about leveraging the power of insights and data to essentially help you with your business as a digital publisher. And so one of the things that I want to turn everybody on to today is big data analytics. So for those of you that aren't using Ezoic, or for those that have had a chance to dig into big data analytics before, there's a lot of really interesting insights about audience engagement in there, like actual engagement, not just session duration, but how the audience is engaging with the content. But one thing that I want to draw your attention to is this real-time revenue. So what you're seeing right there in the screenshot to the far right is the active visitors on a site, and then the predicted revenue from those visitors from all demand sources on the page. That is something that's available for free inside of Big Data Analytics. If you use Ezoic, you have access to it today. If you don't, and you would like to just get some of these insights, get some of this data, you can use that link at the top of the page, and a member of our team will help you access those analytics. That said, we're going to take a very short break. So it says 10 minutes. We're going to take about 5 to 10 minute break. It'll be short. It's just so you can kind of stretch your legs so you don't just kind of slump over in the chairs there. I know, lots of data talks and graphs and charts, as exciting and as fun they are. Sometimes it's nice to get up and move around a little bit. So we'll be back here in 5 or 10 minutes, and don't forget, you are trapped. All right, thank you.